Now we're going to learn how to express ionic compounds using their ionic formulas. So remember that when we have ionic compounds, we have a metal interacting with a non-metal atom. And remember that when we have a metal, it generally loses an electron to become a cation, and nonmetals generally gain those electrons to become anions. So really, when we're writing these ionic formulas, we're writing the interactions between a positive and a negative charge. So here's how we do that. There are 3 different rules. Rule number 1 is that our ionic formulas must contain positive and negative charges. Which means that our ionic formulas are formed between cations and anions. So remember, our positive charges are our cations, and our negative charges are our anions. Rule number 2 is that the sum of the cation charges has to equal the sum of the anion charges. And what this really does is when those charges are equal, we end up with a neutral compound. So the positives and negatives essentially just have to balance each other out. And our third rule is that the formula must be in the lowest whole number ratios of atoms. So it must use the lowest whole number ratios. So let's look at some examples here. So for our first example, let's form an ionic compound between 2 different elements. Let's use aluminum 3+, so the aluminum 3+ ion, and oxygen 2-, so the 2- anion. So the way that we do that is we take these charges and we move them to the subscript of the other atom. So we end up with Al2O3. So that 3 went down as a subscript to the O, and then the 2 went down as a subscript to the Al. And then we want to check, is that the lowest whole number ratio? Can these be simplified anymore? It is the lowest whole number ratio. So we can move on. Now we just need to check to make sure that those charges balance out. So what this means is that we have 2 Al3+, and we have 3 O2- interacting with each other. So let's do that math and check. So we have 2 Al3+. So if we have 2 Al3+, we have a total of 6+ for our positive charges. And if we have 3 O2-, then we have a total of 6-, and the 6+ and the 6- balance each other out. So now we have obeyed all of our rules. We have positive and negative charges. The sum of the charges of the positive and the negative are equal, balancing each other out, and our formula is in the lowest whole number ratio. Let's do one more. Let's use calcium 2 plus and oxygen 2 minus, so we're going to use the O2 minus again. And let's flip our charges. So the 2 will go down to the bottom, and then this 2 goes down to the bottom here. So we end up with Ca2O2. Do we have the lowest whole number ratio this time? No, we don't. So what we need to do in this case is we have to simplify. We know we can divide each of these by 2. And when we do that, we end up with CaO. Now we have the lowest ratio. Can't simplify 1 to 1 any more than it already is. So now that we have the lowest whole number ratio, now we can check our charges. So we have 1 Ca2 plus equals a positive charge of 2 plus, and we have 1 O2 minus equaling a charge of 2 minus. So now you try to form a compound between K plus and S2 minus. Go ahead and pause the video here, work through the problem on your own, and then unpause when you're ready to see the answer. So in this case, whenever you see a plus charge without a number, you can assume that that is a 1 plus. So that 1 plus is going to go down to be a subscript for the S. And then the 2 minus will be a subscript for the K. So we end up with K2S. Remember, when we were writing chemical formulas, we don't write the ones. We talked about that in the prior video. Do we have the lowest whole number ratio? Yes, we do. We can't simplify 2 to 1 any more than it already is simplified. And now let's check if we have 2 K pluses. That is going to give us a total of 2 plus. 1 S2 minus will give us a total of 2 minus. And 2 plus will balance out with 2 minus, so those check out.